I would probably say this is a BigQuery has a really clear use case for kind of business analytics and like OLAP use cases. So when we get to terabytes or petabytes of data, querying specifically rather than making changes to like streaming data changes or anything, things like reporting, things like doing complex queries where you need rapid execution times on very large data sets is a really, really key use case.
I once worked with a product manager who found who had a report they kept refreshing, and it turned out it cost £50 every time they did so. And so it's nice to sort of be able to put on guardrails to stop very sort of well-meaning things like that.
And then I think lastly, really just optimized queries. I think having the combination of like Hasura ease of use and Hasura's own kind of query optimization tools combined with BigQuery and Google Cloud Platform's own optimization, like SQL and query optimization benefits, I think is incredibly powerful. And so I really think the combination of the two makes for a really compelling like business analytics platform where you can then expose simple endpoints to a variety of users with authorization and permission and security all folded in.
Well, hello everybody, and welcome back to another data and API show where we are actually all about data. For these last couple of episodes, we're really excited to have you join us, and we've got a really big show. I hope you're curious. About BigQuery. That joke landed a little bit hard, but anyways, we have a couple of special guests today. These are not only just some fantastic coworkers of mine. They're not only just fantastic British people. They are, in fact, the people who have implemented a large set of our BigQuery features here at Hasura. So I will allow them to introduce themselves. Abby, why don't you let us know who you are, what you do, and yeah.
Hi everyone, my name's Abby. I've been at Hasura now since February of last year, and I'm part of the team that's responsible for extending support for native backends on Hasura. So Postgres, SQL Server, Citus, and BigQuery.
And Dan, over to you.
Hello, I'm Dan. I've been working at Hasura for about 2 months, and so I've been mostly writing docs about how everything works, which has been a tremendous way of finding out what Hasura is and how it works. So yeah, hi, let's go.
So the job of uncovering things that you don't know why they don't work, or things that you're like, oh wow, that was interesting, and then write it down.
Yeah, very much. There's a lot of I don't know what that is and I don't know what's going on. So that's weighted very heavily at that side. But yeah, that's been great.
Yeah, I'd say that actually probably is going to be the greatest segue kind of going into sort of this talk, because when Abby, you mentioned sort of the data sets that we're supporting as native data sets, and I think that native is a key word there, because we've introduced data connectors, which is something that will allow a generic sort of connector for anything that you would want to bring into Hasura. But like, okay, so we got Postgres, flavors of Postgres, SQL Server, classic databases, stalwarts. But then you've got like BigQuery. So heavily vendored, very specific, totally different workload than any of the other like typical, utility databases, if you will. What is it about BigQuery that it sort of got that special treatment? Was it a matter of timing, or like how is the BigQuery story fit? Yeah, because I mean, like BigQuery itself, it's a very unique sort of workload that you would put on there. I think there's even differences in terms of how it's not relational in the sense of what you would expect. Table, rows, columns, everything like normal. So how did that kind of come about? How did the BigQuery story evolve at Hasura?
Yeah, that's a great question. So I think along with Hasura's typical kind of commercial goals, we have a large part of it. This is an open source product. We have a large part of it that's user request driven. So you might notice in kind of our open source repo that we have a bunch of different issues related to support across different backends. And BigQuery is really no different from that. That was something that came up in a few different conversations. And we had a user in particular who was really, really keen to combine a lot of different data sources and do sort of within BigQuery, so combining data sources within the Google Cloud Platform to do data analytics and processing. And it seemed like a really exciting opportunity at the time for Hasura to be able to support that. And it seemed like that would fit into our model and the kind of architecture that we have to support Postgres and SQL Server rather.
All right, we just had a quick break there for an audio fix, and I think that we're all set now. You know, it's like 2022, and you would just think like we've got BigQuery and Hasura. We should have audio have solved like years ago, but here we are, and what you gonna do? Anyways, so yeah, I think that's actually a totally valid point that Hasura is sort of a coin with two sides. We have an open source angle where we want to solve for the majority use case, but we also see a lot of, you know, enterprise and massive customer uptake where they say this is a great product. And a couple of them are like, we would love to partner with you to see BigQuery become supported. And so that I think actually really fits well to, you know, we were able to work with them and say, how do we make this be available and then become available to everybody? Because it's not just that we want to say, here's your custom data connector. Yeah. That's not sort of our ethos. But yeah, that works really well. When we look at then BigQuery itself, and I'll let either of you pick up which one you want to answer this. So like the BigQuery workload, as far as I understand it, super wide table, all kinds of diverse data sets. Like it's kind of it is somewhat structured, but it's more about storing just extremely diverse amounts of data. Yeah. So what's the typical use case? When do I usually see BigQuery surface in an organization these days?
So Dan, jump in and correct and clarify anything that I say. I would probably say BigQuery has a really clear use case for kind of business analytics and like OLAP use cases. So when we get to terabytes or petabytes of data, querying specifically rather than making changes to like streaming data changes or anything, things like reporting, things like doing complex queries where you need rapid execution times on very large data sets is a really, really key use case. I think as well, incorporating different sources from Google's partners, as well as just like a standard BigQuery SQL data set, you can also incorporate things like CSV and JSON files. I think Google have partnerships with the likes of Confluence and Formatica, and you can import all of this and a variety of other data sources into the kind of Google Cloud Platform resource hierarchy, make use of them in BigQuery as data sets, and then in Hasura you can kind of expose those via a GraphQL interface.
So if we were to look at the separation of big data, as you know, you got data lakes, which was sort of the bucket, we just throw everything in there and hope the bad ones float to the bottom, the good ones float to the top. And then you have the data warehouse, where it's more of a kind of a structured approach to how you're storing these different data sets. BigQuery falls more on the data warehouse side of that paradigm.
Yeah, absolutely.
Now, so when you're talking about it then storing all these different kinds of data, is it common for users to connect? Because you could theoretically, in some of these cases, connect some of those data sources directly to Hasura. Do we see people sort of connect both? Or do we more see people use the BigQuery as kind of the top of the funnel, and then that's the connection so that they have their own teams interacting with the inbound?
At least in what we're seeing so far, definitely the latter. Having BigQuery as the primary kind of data set. So the other data sources that we support are Postgres and SQL Server. What we're not seeing at the moment is any sort of cross sort of joining of those data sets. It's effectively within the BigQuery ecosystem. Folks can incorporate data sets from Google Cloud Platform partners as data sets, and then you would add that data set as a new source via Hasura and query it. So it's definitely sort of contained within BigQuery, harnessing the capabilities of BigQuery and their own kind of their own additional features and the data sources that they have access to within the Google Cloud Platform and within BigQuery, and then exposing that through as a single data source through Hasura.
So a lot of the data engineering takes place upstream at the Google BigQuery level, and then where the sort of the Hasura side sort of surfaces is that, I mean, we even have, and Dan, maybe you can speak to this, I believe we actually have some safeguards on place when you connect initially, so that you actually have to set like query depth, right? Or things like that, because somebody could theoretically blow through the month's budget by running a query and forgetting a limit filter or something. And because it's expensive, like you can definitely host things. I was at a startup once where an unfortunate loop did not break in time, and we were at a conference and got a ping that the company was over, basically. Fortunately, Google was chill about it, and we were able to work out some credits and stuff. But that was one of those like, oh, by the way, your company's dead kind of moments. But yeah, so and those were test data too. It wasn't actually even for anything valuable, which was unfortunate. But yeah, so the story behind that, I guess, is that when it comes to bringing in BigQuery, what kinds of concerns, what kinds of patterns should somebody sort of put around that integration to make sure that they're surfacing? Because Hasura surfaces a lot of power features, but you also don't want to give those to everybody. And we're talking about a lot of read layers, a lot of BI kinds of use cases. Business analysts are always trying to figure out how to unlock the hidden depths of your data for something or other, and they're going to create very complex queries very quickly. What kind of safeguards does our integration have that allow us to sort of say, like, you're not going to shoot yourself in the foot by putting BigQuery into this tool?
Yeah, so we have a configurable maximum levels,
depth or returns or
depth. So it works as so if you say set it to 1,000 and you had 10 things, you would get, and they had things inside them, you'd get each one had 10 things inside, you'd get 100 entries, not 1,000 entries, if you know what I mean. So it's like yeah, that would be the
it's like a total, yeah, it's a total
you can't
return, right?
You can't, yeah, it's a total return rather than you letting yourself recurse yourself into some severe problems, which is, yeah, as you say, very, very reassuring. I once worked with a product manager who found who had a report they kept refreshing, and it turned out it cost £50 every time they did so. And so it's nice to sort of be able to put on guardrails to stop very sort of well-meaning things like that happening.
Hey, look, to the audience, if you're able to bring 50 pounds of value every time you look at the chart, go for it. But if you can't, then maybe you should check. Yeah.
I think they did. I think at least £25 worth of value.
At least 25. Yeah. So you're only losing 50% ROI on the per view. So
yeah, I think that's fair.
The other thing I'd mention there from the Hasura perspective is the ability to track and untrack tables. So with every data source that you add, you're not automatically importing and exposing in the schema all of your tables, or the entire data model. You can do quite a sort of a granular access thing. You can import a data source, and then for each source, you can decide what specific data in the context of BigQuery you're tracking and untracking, i.e. what do you have access to via the GraphQL API. And I think this is also another mechanism that helps limit exposure. Also, we're not doing a huge query of all of the available data sets.
Because that's common, and sorry for the camera shake there, everybody. That's quite common, right? In that when you have the data warehouse model, you'll often have sort of the raw capture, oftentimes an underscore table set or whatever, and then you will have sort of these cleanup functions that are either normalizing or they're combining or other functionalities. And you may just want to say, hey, we don't want to include any of the underscore prefixed tables because they're just not things that we want to surface to the business units or to whoever else. So when it comes, I'm trying to wrap my head around this, because like BigQuery doesn't really have primary IDs, right? When it comes to their tables or any kind of a sense of an identifier. So like how did you guys actually go about enabling the ability to query this in a system like GraphQL that oftentimes for unique entries and unique rows kind of looks for or expects unique identifiers?
So at least in the context of relationships and also GraphQL queries, and Jesse, I might have my information a little bit wrong, so please feel free I might fact check this afterwards. But at least in the context of relationships and GraphQL queries, for BigQuery, we use the data loader approach. So we effectively run a query, exposed tables that you have in a GraphQL in the Hasura data set. And then for each of those things that we want to potentially join against, we then run another sort of batch query. So it's effectively a multiple layer of queries, and then we're joining them afterwards in raw SQL.
Okay. All right. So I guess that actually makes that probably the only way to do it when it comes to BigQuery. Otherwise, you really don't have nothing to join these tables across when it comes to GraphQL land.
Yeah, but it's interesting because that's it's what we are effectively going. That's not the primary use case for BigQuery. It's not an effective like BigQuery doesn't have a lot of use cases for joining lots of data. It's I have lots of kind of data that across a few different data sets that I want to be able to compare rather than joining them directly. Hasura definitely accommodates that in an optimized way as well. We're just using standard SQL joins, but we do have to be careful about the amount of data that we're loading in, and that's something that both Hasura and the Google Cloud Platform can accommodate in a few of the ways that we've discussed already.
So that actually speaks interestingly to where and why a user would bring BigQuery into Hasura. So it sounds like more like this is a case where Hasura is bringing a lot of value as a data access tool for the rest of the ecosystem. And they're like, well, we don't want to switch to another tool just so we can do our BI analysis, even though they're probably very shallowly, if at all, using GraphQL's killer feature. They're just saying, hey, we want to keep our tooling consistent here across the stack, and want to bring us more data sources in. That's actually a really interesting perspective in terms of how users are sort of adopting Hasura, not just as this is my quickest way to GraphQL, which it is. It is actually a tool where people are wanting to say, like, this is a really convenient and helpful way to put guardrails and normalized access patterns and permissions and controls all around how do we access this data.
Yeah, I think the permissions thing is quite interesting as well, because I think Dan and I have both, actually before working on BigQuery, I think Dan, you'd had probably even a bit more experience with BigQuery in the Google Cloud Platform than I had. So this was definitely a learning adventure for us in terms of supporting BigQuery on Hasura. And one of the things that we learned that was quite different to our experiences with Postgres and SQL Server and other backends we support is BigQuery's identity access management, so like their IAM policies and things like that. And the Google Cloud Platform have a incredibly like nuanced and intricate IAM policy. So who do we grant access to various service accounts or Google Cloud Platform resources? It's incredibly intricate and can be a little bit
cryptic.
Cryptic, yeah. Cryptic is the word. And I think one of the interface across all of your data sets, where you can either encode permissions in the metadata and upload that, or you can go via the Hasura console and establish which users you'd like access at a very granular level on a row and column permissions basis. And I think that simplicity of defining and using permissions is a really nice advantage of Hasura in this case.
Yeah, because I know, I mean, we love Google. and we use Google for a lot of things. I don't know how many times I've just really not understood services that I have access to, like in terms of I can read from that or change something via an API. But then if I try to click to go look for a setting or something, it's like, well, you don't have access to view the panel. You have access to the data and the content, but you don't have access to the configuration. Like, it's like, what do I like? What button did I miss where I can't actually go to the GUI, but I can do it from the API? Like, so there's a lot of cases where this becomes confusing. I think having that case where we're going to get this connected to one tool, like all you got to do is just get that configured once. And then for the rest of your entire organization, you're able to sort of do access controls, inherited roles, or whatever else you would want to be able to do to spread this out across your org. So that's actually a really good point. It's simplified user access for BigQuery is probably the next USP that we can be pitching on the website. But yeah, that's pretty cool. So we've released a few features recently. Like we had a couple, like a community call a while back. We talked about some things. What are some of the latest changes? Because we have not limitations, but we've made some opinionated choices around how we support BigQuery, and that's one of the big misnomers I think we see a lot of users coming to Hasura is they assume that we're just going to normalize access to all databases identically across the board. And that's just not what we're going to do, because you're not using every database in an identical way. They have very different use cases. Like you were saying at the beginning, Abby, the kinds of use cases we see for BigQuery, very read heavy, like almost exclusively read heavy, like read use cases. And so I don't think we even to this date, we don't support mutations and writing and updating for BigQuery, right?
Nope.
So it's a one-way funnel. You configure everything you need in BigQuery, and then we'll service that in the way that you're used to accessing that data. What are some of the other features or unique cases we've enabled with BigQuery in terms of access patterns and things we've surfaced that you can do with BigQuery?
Actually, I would just add one caveat to that sort of mutations piece is that we do have, it's an admin facing, but it is effectively a SQL estate patch that we're in the Hasura console where you can run arbitrary SQL commands against a BigQuery data set. That kind of use case is again, very much admin focused rather than just allowing users to run arbitrary queries from Hasura on a BigQuery data set. We would imagine the typical use case would be if someone wants to add or change data in BigQuery, then they would do so either by importing a new data set or editing the data set in Google Cloud Platform. I think other sort of things that we've enabled, I would probably say one of the decisions that we've made to stick with the kind of semantics of BigQuery rather than try to unify them in a single interface with Hasura is maybe something that Dan can speak a bit more to, which is not parsing stringified numbers. So in BigQuery in particular, integer, like all numeric values are string encoded. And I think maybe Dan can speak to more of the details about why that is. We had was to effectively parse the string response for numbers, and to make GraphQL response parse strings into numbers. And we made a conscious decision not to do that because that would effectively defy the semantics of BigQuery. We didn't think at the time that it was but we didn't think there was a very clear of defining the BigQuery semantics, and weren't sure what other implications would be of that change. So that's one decision that we've made, kind of in favor of BigQuery,
which fits to the different workloads, right? So that fits to the idea that we're trying to embrace the database and the workloads the databases do, in the way that database was intended. So if you've got a BigQuery, platform or tooling, you want to be able to consume this in a way that you're going to be expected behavior for BigQuery, as opposed to saying we're just forcing everything to look the same and act the same and be the same. That's just not what you do with databases.
Yeah, so, exactly.
the thing with the numbers as well. The reason that BigQuery makes all the number strings is that BigQuery, being big data, does like 64-bit numbers, which for JavaScript's mind is just too much. So JavaScript, you see, if we expose them as numbers, we'd have an interface where if you suddenly put a certainly large number in your data set, suddenly your front end would explode. And so that doesn't really feel particularly responsible. So, you know, the thing to do is for us to give a string, or we can guarantee we're always going to give you a string. And then it's up to the, you know, the front end to parse that as they will. And then it leaves the error handling to the front, you know, to the implementer. And if they want to deal with that, then they can deal with that in a localized. And I think it makes it easier to do sort of much nicer UI patterns.
So JavaScript crippled Google's ability to be able, like, just crushed them and said, no, we're not going to let you store big numbers.
Brendan Eich only likes small data. He's famous for it. Famous fan of only the smallest possible data. So yeah, that wasn't going to fly with him.
Very nice. Yeah. So what else were some of so we have these string values, and I actually wanted to come back real quick to what Abby had said about the API escape hatches, because there's another feature that really you should have a very good reason why you would use this. But when you create an event trigger or inside of Hasura, you can actually run arbitrary SQL through an event trigger. It's an option to not just do like an endpoint resolver, but you could actually run arbitrary SQL, so that theoretically you could do some data manipulation. Is that same SQL interface also then available for the BigQuery manipulations, or is that more for the traditional SQL databases?
I think from a use case perspective, we definitely had the more traditional kind of relational DBs with that in mind. I don't know for certain if we support event triggers on BigQuery.
Okay.
Yet, but it's
yet.
That's a product discussion.
I can imagine event triggers being one that we'll probably see people want to do.
Yeah.
But it will be hard to solve for. When we're talking about the level of data that often streams into BigQuery, it can be you know, millions of rows per minute if you're talking about some of the right data sets.
Yeah.
And we want to be mindful.
I mean, you can certainly imagine. Yeah, you can certainly imagine the use case here, though, right? In terms of, you know, business intelligence and analytics, and perhaps incorporating some like business logic and rules in using Hasura event triggers. But yeah, I think we probably just have to really consider how to either support users to use that responsibly on BigQuery in either documentation or potentially guardrails in Hasura, or, you know, restricting some capability somewhere.
Nice. So what are some of the other Hasura specific BigQuery things? And just for the audience, we actually, I found out this morning that I'll be able to get a BigQuery developer advocate coming on in a few weeks. So that'll be a lot of fun. And it looks like we actually don't do events on BigQuery just yet, but I think we both kind of assumed that was the case. Something that, again, it needs to be handled with care. We're not talking about standard queue sizes when you're talking about BigQuery databases. So what are some of the other features that from the Hasura specific side, that we've added to the BigQuery story, or ways that people work with BigQuery inside of Hasura itself? Dan, I think you did some work there, or Abby, either of you can take it.
I've done recent work on tests, so I don't think I've done anything. I don't think I've done anything user facing. What was the work that Rakesh did? So
that was computed fields.
Yeah, that's the freshest thing in BigQuery, isn't it? I think, but I couldn't tell you what it was.
That's actually quite cool. Okay, so we actually have computed fields now in BigQuery. Is that even landed yet in terms of the release?
Yeah, this is live. This is in production. So I think for at least the last maybe month or so, we've had computed fields available in BigQuery. Maybe we can share the docs here afterwards. But they're effectively like dynamically computed virtual fields that you can access via the GraphQL API. So you can, actually, this is specifically in the CLI, not yet the console, because we don't yet have interface console, but just enables us to compute and query functions in an ad hoc relatively SQL. So we can define a kind of table function in standard SQL, and then expose that via Hasura's GraphQL API on BigQuery.
That's really cool. Do we have a demo of that feature, or we have a demo of some sorts, right? That we can have a look at BigQuery connecting.
I think in our last community call, Rakesh demoed computed fields, and again, this is in the CLI, not yet in console, but this is live and in production in the latest version of the GraphQL engine.
That's super cool. Do we have the ability to see like a BigQuery connection and just kind of have a look at sort of what kind of data you get back? Do we have something we can look at today?
I've got something. I've got something right here. Shall I share my screen? Would you? Let's see.
Yeah. I'll have to probably put you on stage here.
So imagine that, if you will, that we are in the Hasura GraphQL console. We're going to add a new data source from BigQuery. So we're going to connect a data source. We're going to call it BigQuery. We're going to choose BigQuery. Now, in a bit of here's some work here's one I made earlier. I already have my service account key in an environment variable exposed here. So we're going to connect to our test project, which is called, of course, Regency Polecat Beehive. And we've got a data set on there called horses, about horses. Now, we talked about that global select limit earlier, which is going to stop me spending all Hasura's money. So we're going to leave that at 1,000, which should give us enough horses, I think, for that. I feel that this will still provide us with sufficient horses. So
that's not dollars per query, right? That's limited.
Minimum spend.
It is possible with BigQuery to confuse that. So
yeah, so we've got this has got a couple of tables. We're going to track them both. So we've got a list of horse names and also some information about horses that have won the Grand National, which is a famous horse race in the UK. I don't know if it travels the reputation of this horse race. So as we discussed earlier, we can add a relationship. So we're going to add an array relationship because we know that called horses, and I want to reference the Grand National winner. So I'm going to say that the name of the horse in the list of horses, and I'm going to link that to the winner, the name, because the winner is the string name of the Grand National winner for a given year. So now that I've got this, we can do some stuff. We can merely look up some horses, some nice horse names. Again, we've got a limit of 1,000 here, so we're not going to get in trouble. As you can see, we've got some lovely horses here: a breath of snow, a burst of orange, a designer classic, a fairy's kiss. These are all excellent horse names, but I'm interested in horse names that have the word egg in because I am juvenile. So if we're using this here, we're using this where clause here, and we're looking at the string field 0 is the name of the horse names, and we're looking for anything that's got egg in it. So we've got Benny eggs, boiled egg, Easter egg, egg freckles, egg tart, just eggs, green eggs and ham, nest egg, and pace egg. That's pretty great. Now, I mean, we could also, I want to know whether any of these eggs are winners, right? I want to know if, so I can look at the aggregate, which is like all of the Grand National winners that are related to this given horse name. And I want to look at how many of them there are. So for instance, we can tell you that Benny Eggs has never won the Grand National. Boiled Egg has never won the Grand National. Easter Egg has never won the Grand National, as you can see. And as noticed,
don't name your horse with egg in it if you want to win a Grand National.
Yeah,
we've already gotten our first business intelligence out of our data set here.
Absolutely.
Can we filter by wins? Can we say, like, use a compound query where we could say where the name has egg and the count is higher?
We absolutely can. So what if I told you? We're just going to say that we use, there is probably a smarter way to do this. However, just by filtering that there's a winner there that has an egg. Oh, right. So there's never been, I think, in answer to your business intelligence question, there's never been a winner with the name egg. So I can tell you. I can tell you from previous checking that there isn't a winner with the name cloud in it, and that winner was called many clouds. So now, I guess I suppose we can also look up rather than just talking about the aggregate for this, we can also just look at I need to here this winner. We can also like find out what year that was, right? Because that's kind of interesting. So now we can find out that Many Clouds was the winner in 2015. That's some horse facts for you.
Right from the horses themselves, here's a question. So horse names is actually are unique, generally speaking, through the normalized federated world of horsemanship, as far as I understand. If you've got like crossover between the U.S. and the British and the German horse ecosystem, generally speaking, names are somewhat unique, and there's a lineage that you can track oftentimes where the letters need to actually play forward. So you'll actually have, which is what leads to sometimes the funny names, but you'll actually have like a first letter has to be repeated or something like this. Yeah, fun facts. But do we have the lineage? Do we have like the paternity line with, usually it's tracked by paternity. Do we have that line tracked in the data set by chance? I'm just curious. Because if we did, we could potentially do a relationship, but no.
I would love that. And furthermore, I'd also like you to be a guest on my horse podcast. But I'm afraid that the information that we have here is only a list of horse names, for instance. I mean, if we
well, we saw a trainer there, right? What else do we have underneath then?
So we've got like, and if we look at like this query about like Grand National winners, so this is like here's some just Grand National winners going back. So this is the year 2022. So we've got stuff like the jockey, the winner. What else have we got? Can you see on the left hand side here? This is
yeah.
We've got a winner. We're filtering out winning time over here, if only because there's actually a few years where, because of COVID, there wasn't any Grand National. So I want to get rid of that, because that was
So because it's a fun word to say, would we be able to discover what the winningest owner of all time is based on this data set? Because we have the owner of the horse.
We do. So if we started with I suppose we want to look at, we want to see the Grand National distinct on owner, and I think, can we do a count? Maybe that seems. I'm definitely at the edge of my.
And I'm gonna push it over the edge too.
It should be live.
So this is not. Hang on, that's not. That's an aggregate. That's just a count of all, isn't it? So if I just take the distinct owners out, it's just not having that, is it? Grand National winners.
And this would probably be where you generally need to put this into a different tool to slice and dice afterwards. I mean, I was just curious if there was a way to sort of maybe even order by the owner, and then an aggregate of their win. But we don't actually have aggregates in order yet, do we?
I don't think so. Abby,
there's work being done on that. But
aggregates in the where clause is that that's what we're working on at the moment. Yeah, we're working on it. It's not yet live, but it's in the pipeline.
Okay, then we also don't have to torture you with the live queries, but this would be a case where then you'd be able to at least have this data, and you'd be able to, the data set you would need would essentially just be a subset of the horses that have won plus their owner, and then from there you'd be able to very simply put that through any kind of a typical BI tool, group by, and then be able to filter that data. So this is a case where you'd be able to get that data set you would need and punch it right into a tool that would allow you to actually spit that out in a meaningful way.
Yeah, absolutely. So I'm absolutely nerd sniped by this now. I'm so sorry. I'm going to lose.
Yeah. So you probably, yeah.
Can I? What do I want?
And this is where it gets fun.
I'm gonna pull back because I'm operating over the edge of my. I'm operating well over the edge of my competence.
Yeah. Is this data set actually public?
No, I made it for my horse.
You made it.
I created this.
Do you actually have a? Okay, now I'm gonna put my foot right into it. Do you actually have a horse podcast?
No, I don't. Sorry, no.
That'd be fantastic. That would be such a great piece of detail.
But if you agreed to go on it, I would start that podcast.
So I used to help a horse owner track the lineage and the bloodlines of his breeding program for horses. And one of the things that I had done, because I was not going to be bothered with going through a bunch of old paper documents, is I had hired some nearshore workers to do that for me. And because I was a little bit database shy in my earlier days as a developer, they then transformed all of this into YAML documents, which I was then running through like static site generators. And I can say from what I've seen here, BigQuery beats a handful of YAML files for data such as this.
I feel like BigQuery is the computational equivalent of nearshoring just loads of computational resource to do your things. It's pretty close.
Is that going to be the
more sustainable
line in our docs?
Yeah, but probably in a more sustainable and like, you know, fair way.
Yeah, absolutely, yeah. Without any of the obviously questionable.
Without any of the downsides of mechanical Turk that are obvious for those that are not familiar with those controversies. Yeah, okay. This really does show the value. Could we let's do one last piece of the demo? Or is there any other piece you wanted to show? Otherwise, I can have us do maybe one last show here.
No, that's all I have in this respect.
So let's just discuss very briefly. Let's say I wanted to do that case where I wanted to see the horses. So the horse names that have one along with their owners. And let's see if we can just restify that endpoint. So we would show a good use case where we would be able to create a very scoped down query that's coming from our BigQuery data set that we're then able to give to our BI team and say, this is the URL that you have access to. It is maintained, it is locked down, it is controlled, and you're not going to hose our production data set if I give you access to this REST endpoint. So if we were to see the data, so we got the actual winner. Maybe let's add the year on that too.
Yeah, let's do it.
So we have a nice data set there. If we were to then restify this endpoint, we can call it something like, I don't know, we can call it like horse winners. Yeah.
Perfect.
And then give that a GET request.
Let's do it.
And then we would actually have an ability there to just pass that URL into Google Tables or any of the other Tableau or any of the other tools out there to be able to then do our group buys and things to find our winningest coach or owner.
Yeah, and I would say all of that is backed as well by Hasura's kind of authorization and permission things as well.
Fantastic. Hey, so we're just a little bit over on time. I had promised you. Do each of you have? I'm going to pull your screen off here. This is a fantastic demo. I mean, anytime you can add horses to the Data API show, I'm all for it. We asked you each if you could come up with sort of 3 tips and tricks or 3 things that were sort of like further learning or things that you really enjoyed about working with this. What are 3 things from each of you that would be things that you would like to point people towards when it comes to BigQuery, Hasura, anything? Abby, we'll go with
A
you
few
first.
of a few of mine were, well, to be honest, just generally with Hasura, but in particular giving access to BigQuery is just how easy it is to get up and running, really, with Hasura and on BigQuery. If you have a BigQuery account and a few users that you want to allow access to via like a standard API or a REST endpoint, it really I mean, Dan illustrated, it really does take just a few minutes via the Hasura console to enable support to as many BigQuery datasets as you like, as well as any other databases that you might also have access to, like Postgres and SQL Server as well. So just the ease of getting started is, I think, a massive benefit of Hasura, as well as some of the kind of permissions and access, simpler access management policies that we discussed earlier. One of the things I like about BigQuery and Hasura is that Hasura supports geospatial operators, and so one of the big use cases of BigQuery is kind of might also include location data for the purposes of geospatial analytics. So like, how's my delivery service doing? Where are all of my delivery drivers or my users based, and doing a bunch of business analytics around that. All of that is very easily supported in Hasura because we support all of the standard. It's the equivalent of like Postgres for Postgres, but I think it's BigQuery, yes, or something for BigQuery. So you support all of the geospatial operators there. So import some location data if you like, and see what we can do there. And then I think lastly, really just optimized queries. I think having the combination of like Hasura ease of use and Hasura's own kind of query optimization tools, combined with BigQuery and Google Cloud Platform's own optimization, like SQL and query optimization benefits, I think is incredibly powerful. And so I really think the combination of the two makes for a really compelling like business analytics platform where you can then expose simple endpoints to a variety of users with authorization and permission and security all folded in.
Great. Yeah. Fantastic. Dan, what do you got for us?
So things that I like. I mean, the thing I find most exciting about BigQuery is just there's massive public data sets that you can go. And that's like both just super interesting to have all this information. There's a lot of COVID stuff at the moment, which still feels like a bit of a downer. But if you're interested, a lot of it's very COVID essentially, got like huge weather data. So I suppose probably some good geo stuff like Abby was mentioning, and that's got just a great way to learn BigQuery and hopefully learn something along the way, if you like. So if you have a regular BigQuery account, like a free one, you can just browse the query sets, bring them into the Google Cloud Console like you would any other data set, and just work on them in a read-only fashion. But that's super interesting. I think the console itself is really lovely, and the thing of note that I like the most. I mean, I suppose with any database, you end up bolting on all this tooling, but BigQuery is built on the tooling as a first. That's sort of as a first principle. That's part of the way you access it. I think that's a huge value add for sort of non-developers to access your data and stuff like that. Like, I think it's huge that I think it's just so interesting and helpful that if you want to get information that's not from development sources, then you should make it easy for non-developers to create data and to access data. That's sort of super helpful and super useful to me. And I suppose, I think the most attractive thing to me as a developer is that you don't have to operationally run it. Like, I don't actually have to re-index BigQuery. It's just there. I don't have to think about read replicas for BigQuery because it's just there. I assume Google, every bit of information I put there, Google have, copied into 100 server farms, I assume. I don't have to think about making sure that I'm scheduling a maintenance window and it's not going to be in a peak traffic time, and my peak traffic times are in different places around the world. There's all this stuff that I just don't have to think about. And I love that because I'm a lazy man at heart, and BigQuery has a lot of benefits for lazy people like me.
Well, I'm not sure if we're going to use that as the soundbite. BigQuery is for lazy people. But I do think that when it comes to the low ops approach of, for those that know what's happening under the hood and then know they don't want to do that themselves, that's where tools like Hasura, tools like BigQuery, like a lot of these different services really come into play, because it's like, okay, you're not a black box of magic. I do understand what's happening under the hood, but I don't have to actually write this stuff myself. I don't have to write these connectors. I don't have to write these resolvers. I don't have to write these storage engines. And I think that's where I think one of the real powers between BigQuery and especially BigQuery with Hasura come in, is that we're actually able to say, get the relational data like that you can query, get the massive, wide table storage alongside the rest of your production databases, analytics plus app data living inside of the same system that you can control and ship in the different places, and being able to say you get all of that with very little configuration effort only, without actually having to code any of it. And then you're up and running and able to kind of monitor and see how that works. And yeah, super exciting stuff. I really, really appreciate having you both come on the show today. BigQuery's got a big future with Hasura, so we're super excited about that. And we're only just now starting. So if you have features, if you're a BigQuery expert and you got a question about like why we don't support X, Y, or Z, make a ticket. We'd love to see it and see which things are the community is actually wanting. Because I mean, the whole idea of having BigQuery in the first place was community driven, and so you are the ones using it and shipping with it every day. Maybe you are creating horse podcasts. We don't know. But we'd love to find out what it is you are building with it. Let us know. And with that being said, we will see you all next week for next week's database show. We're doing databases for the next several months. I've got a lot of guests lined up for this topic, and this is going to be a lot of fun. So anyways, that's it for the Hasura side. We're really grateful for you all joining today. And thanks again to Abby and Dan. That was a lot of fun. So
thank you.
Have a great day, everybody. And we will see you all next week.